Hello and welcome to our second video. Today we're going to cover Chapter 3, Decimals. We see decimals every day when we deal with money, but let's take a closer look at a decimal number and its place values. We'll start with the number 324 and 576 thousandths. Okay, that is the official way to say this decimal number. We start here on the left. This is our hundreds place. Right, we have 3 hundreds here. Our 2 is in the tens place, 4 in the ones place. We should all be familiar with these. Once we pass that decimal point, we are now going to start with the tenths place. So the tenths place, it's just like the tens place but with a TH at the end of the word. And then we'll see that pattern for everything after the decimal. Okay, our tenths place, then our hundredths place, and then our thousandths place. And you guessed it, our next number here, if I were to add another, would be the 10,000ths place. We have our ones, and then everything goes out from there. To the left, ones, tens, hundreds. To the right, ones, tenths, hundredths, thousandths, 10,000ths. So just add that snake sound at the end of each place value. One other interesting thing about our place values, so here I have the number 0.5. Okay, this is in the tenths place. I have 5 tenths, and as we saw with fractions, 5 tenths is 5 tenths, written like this. All decimals can be easily converted to fractions just by writing your number over the place value that it goes out to. So for example, 0.206, that will be equal to 206 over, we made it out to the thousandths place, so we will have 1,000 as our denominator. So 0.052 will be 52 over 1,000. And we can ignore this 0 here. We don't normally write zeros in front of our numbers. Right, so we can leave that off. Again, we go out to the thousandths place, so 52 thousandths. So when we go then to add our decimals, the main thing we need to keep in mind is to keep our decimals lined up so that we are adding things in the same place value. For example, if I have 2.34, I'm going to add to it 5.23. My decimals need to be lined up so that when I go to add, I'm adding 2 numbers here in the hundredths place, and then my tenths, and then my ones. So again, 4 plus 3, we get 7, 3, 2, is equal to 5. Our decimal we just bring down, and 2 plus 5, 7. Alright, that's all there really is to adding decimal numbers. Just make sure the decimals are lined up and everything will be okay. So we'll do one more example here. Say I have 4.02. I'm going to add to it 2.7. This 2.7 has no number in the hundredths place, but that is okay. I can add a 0 to the end of any decimal number. So if I had, say, 1.2, I can add as many zeros to the end of it as I want, and it's still that same value. I don't need all of these zeros, but I can put them there, especially when I'm adding, so that I have that place value holder. So we go to add these two numbers. Again, we just add things in the same place value. 2 plus 0, 2, 0 plus 7, 7, 4 plus 2, 6. And that decimal comes straight down, 6.72. When it comes to subtraction, Alright, we're going to do the same exact thing. Take, for example, 437.56, and we're going to subtract from that 41. Again, I want to keep the decimals lined up. This 41 here has no decimal. Any whole number has a decimal at the end of that number. So I can add that decimal point there. And then to keep things lined up, I can then add zeros after the decimal point without changing the value of my 41. So now we just subtract like normal. 6 minus 0, 6. 5 minus 0, 5. Our decimal point comes down. 7 minus 1, 6. 3 minus 4, I need to borrow from my 4 and then give 10 here. So 13 minus 4, 9. 3 minus nothing, 3 minus 0 is 3. So 396 and 56 hundredths. We can do another subtraction problem. Say instead now I have 27 and I'm going to subtract from it 18.36. Okay, again here I definitely need to add those zeros after the decimal point so that when I go to borrow, I have something to give it to so that I can subtract correctly here. Right? 0 minus 6, I can't do that without borrowing, so I'm going to borrow from my 7, becomes a 6, give that to the next 0, borrow from that, becomes 9, and then give that to my very last 0 here. So I have 10 minus 6, we get 4, 9 minus 3, 6, 6 minus 8, I need to borrow again. So I have 8 and then nothing here. Put my decimal point straight down. So 27 minus 18.36 is 8.64. Alright, you've heard me say the proper way to say a few decimal numbers. Let's practice that once more before we move on. If I have 33 here, 0.7605. Okay, I say the number in front of the decimal point as I normally would, 33. The decimal point is the only time that I will ever use the word and when you are saying a number. So 33 and then you say the number after the decimal point, just making sure to add the place value at the very end of that number. So here 7,605 10,000ths. Okay, so the full number would be 33 and 7,605 10,000ths. Another number, 2.04, I would say that as 2 and 400ths. This number here, 7,632 and 93,200 thousandths. That would be the proper way to say that number. Again, that's because 2 here is in the hundred thousandths place. Right, here's our tenths, hundredths, thousandths, 10,000ths, 100,000ths. When we multiply, it does not matter if we keep the decimals lined up. Right, say we had 3.2, I'm going to multiply that by 0.41. I just multiply this like I normally would. Right, start with my 1. 1 times 2 is 2. 1 times 3 is 3. I go on to my next place value. 4 times 2 is 8. And now that goes under the next place value here. I can add a 0 here to hold that place value so I can keep this lined up as I go to add it at the very end. So then 4 times 3 is 12. Bring that down here. Right, and 0 times everything is 0, so I don't need to do that. I go down here to add those two together. 2 plus 0 is 2. 8 plus 3, 11. Carry the 1. 3, 1. Now I need to take a look at my decimals up here. My 3.2 has one digit after the decimal. 0.41, I have 2 digits after the decimal. That's a total of 3 digits after the decimal. My 3 digits after the decimal. So when I go to put my decimal point, I need to go 3 digits in and put my decimal point right there. So 3.2 times 0.41, I get 1.312, or 1 and 312 thousandths. Let's take a look at if we multiply 1.03 times 10. 0 times 3 is 0, 0 times anything is 0, so I don't need to do anything there. 1 times 3 is 3. Again, I need to start at the next place value over. 1 times 0 is 0, 1 times 1 is 1. Add that all up. Okay, count my decimals. I have 2 decimal places after my decimal, none here, so my decimal point will go 2 over and right there, 10.3. Well, this, if you look here, is the same numbers as what we were multiplying by. All that happened is our decimal point moved 1 to the right. Anytime you multiply by a power of 10, 10, 100, 1000, all that you'll be doing is moving your decimal point by the same number of places as you have zeros after the 1. So for example, 3.072 times 100, all I will get is those same numbers, 3072, and then my decimal point will have moved from where it was 2 places to the right, right here. So my 3.072 times 100, I get 307.2. Let's try some division now. Let's take 1.38 divided by 2.4. One thing we can recall from our fractions video is that fractions represent a division problem. So I could rewrite this as a fraction, 1.38 over 2.4. And then you also recall I can multiply a fraction by a number over itself. Let's say, for example, 10 over 10. Right, and that won't change the value of this fraction. Right, what this does now, anytime I multiply by 10 or a power of 10, I'm effectively going to be moving that decimal point, as we saw earlier. So what I have now is 13.8 divided by 24. This is the same problem as 1.38 divided by 2.4. This will also make our division much easier. Right? When we're doing our long division, it'll help us know where to put our decimal point. Anytime we're doing division with decimals, the first thing we have to do is what we're dividing by, that 2.4, we have to get that decimal point to the end of the number. Right? Another example here, right, if I had 6.8 divided by 1.7, I would first need to change this to 68 over 17 before I divide. So we had 13.8 divided by 24. I will write this out in long division. 13.8 divided by 24. So now I'm asking myself, how many times does 24 go into 1? Well, it doesn't. So 24 goes into 13. How many times? Well, it won't fit in there. So again, 24 now, how many times does that fit into 138? 24 goes into 138 5 times. So I write that 5 here. So 5 times 24, I get 120. Subtract that from my 138, and I have 18. So now I ask, 24 goes into 18, well, it won't fit into there. What I have to do to keep going is I can add that 0 after the decimal point, so that I can bring down my 0 and keep going with my division. So now 24 goes into 180 7 times. My 7 goes up here. 7 times 24 is 168. Subtract that. Borrow from my 8. I have 12 left here. Again, I don't want to end with the remainder, so I'm going to add another 0. So I bring that 0 down. 24 goes into 120 5 times. 5 times 24 is 120. So I have no remainder left, so I don't need to bring anything else down. My decimal point comes straight up, and I have my answer here, 0.575. If I add my 0 in front of the decimal point, 0 and 575 thousandths. Next, let's do 8.8 divided by 3.2. Now remember, we have to change our decimal point so that it's at the end of the number. Right? If we are moving our decimal point one place to the right for what we're dividing by, we have to also move it one place to the right here, because we have to remember, right, this is 8.8 over 3.2, right, which will become 88 over 32. Again, multiplying our top and our bottom by 10. It's effectively what we're doing here. So back to our problem, 32 divided into 88. 32 goes into 88 twice. 2 times 32 gives me 64. Subtract here. 88 minus 64, we get 24. So now I have to add a 0 after my decimal point to bring it down. 32 goes into 240 7 times. 7 times 32 is 224. Subtract that. Borrow from our 4. So we have 16. Add another 0, bring it down. 32 goes into 160 5 times. 5 times 32 is 160. Subtract that, we have no remainder left over, so we are done. We move our decimal point up from where it was, and we have 2.75, or 2 75 hundredths. Let's now take a look at rounding decimals. If I have 32.9702, and I want to round this to the hundredths place, right? Anytime I round, I start at the number I want to round at, I look at the number to the right, and that will help me decide, do I round up or do I round down? If this number, okay, is between 0 and 4, I round down. If that number is between 5 and 9, I will round up. 0 is between 0 and 4, so I'm going to round this number down, right, to 32.97. That 7 stays the same because this number is going down. It's dropping everything here and becoming now just 32.97. What if I rounded this number to the ones place? I then look at the number to the right, the 9. It is between 5 and 9, so I round up to 33, and I drop everything after where I rounded to. What if then I want to round it to the tenths place? I will then look at the 7. The 7 is between 5 and 9, so I round that number up. 32 point, wait a second, 9, if 9 goes up, it goes up to 10, which will then push up this 2 into a 3. And my 9's place then is 0. So rounding the 9 up, right, changes this to 33.0. Rounding can be convenient when I divide. Say I have 4.7 divided by 1.8. And I don't want an exact answer, I just want an answer to the tenths place. All I have to do then is carry my answer out up here to the hundredths place so that I can round to the tenths place, and I don't have to carry out past the hundredths place. I don't have to do thousands, 10,000, so on and so forth. Sometimes we'll have division problems that could go on forever, and we don't really want to do that, so we can round just by carrying it out one place further than where we want to round to. So we start here with moving our decimal point to the right, and then we divide. 18 into 47 goes in twice. 2 times 18 is 36. We have 11 down here. We add a 0 after that decimal point and bring it down. 18 goes into 110 6 times. 6 times 18 is 108, 108. Subtract that, we get 2. Bring down our 0 again. 18 goes into 20 once. Subtract that, we have 2 left over. We see here our decimal point was right here. I wanted my answer to the tenths place, right there, the 6. So I look at the 1, right, and I can now round this to 2.6. That way I don't have to keep going, right, as we see we would down here. This example is also called a repeating decimal. We had 2 here that we were dividing by. We brought down a 0. Right, 18 goes into 20 once. We had 2 left over, so we would have added another 0. Right, and 18 again goes into 20 once. And we create this pattern. So my 0, 18 into 20 once, and I have another 2 left over. This will then repeat forever with ones. 2.61 repeating. We can also write this decimal, if we wanted to write our exact answer, as 2.61 with a bar over the 1, showing that the 1 is repeating forever. We don't just have to have one decimal repeat, we could have 2 decimals that repeat. Say this 3.23 repeating. What this means is we have 3.232323 on forever. Or I could have 4.792 with a bar over the 9 and 2, and I have 4.79292 on forever. Or even 3.763 with a bar over the 7, 6, and 3, and that's 3.7637637, so on and so forth. So that is repeating decimals. Let's take a look at averaging. Let's say I want to average my test scores of 85, 75, 92, 86, and 72. To average these 5 test scores, I need to add them all together and divide by how many tests I have taken, in this case 5. Anytime I average numbers, I add them all together and divide by how many numbers there are. So in this case, right, I first add up 85 plus 75 plus 92 plus 86 plus 72. That gives me 410, and that is being divided by 5. So let's go ahead and do that division. 410 divided by 5. 5 doesn't go into 4, but it goes into 41 8 times. 8 times 5 is 40. We have 1 left over, bring down our 0. 5 goes into 10 twice. 2 times 5 is 10. We have none left over. So my average test score is 82. Be looking for decimal answers and decimals in what you will be adding together, what you'll be averaging, since this is a chapter on decimals. We'll finish up chapter 3 by taking a look at fractions again and converting those fractions into decimals. This is really easy, right? We've already seen that fraction is a division problem. We've already divided decimals, so we can put these two together, take my 5/8 and turn that into a division problem. 5 divided by 8, and then divide using what I know about decimals. 8 doesn't go into 5, so I need to add a decimal and a 0. So that 8 now goes into 50. How many times? 6 times. 6 times 8 is 48. We subtract 2 left over. I add another 0. 8 goes into 20 now, twice. 2 times 8 is 16. 4 left over, and another 0, bring it down. 8 goes into 40 5 times. 5 times 8 is 40. I have none left over. My decimal point goes straight up, and put a 0 in front of my decimal. So I have now 5/8 is equal to 0.625, or 625 thousandths. So we can do this with any fraction, just converting it from a fraction into a division problem. So here 3 doesn't go into 2, so I add a decimal point and a 0. 3 goes into 20 6 times. 6 times 3 is 18. I have 2 left over, so I add another 0. 3 goes into 20 6 times, gives me 18. Subtract that, I have 2. If you notice, right, we have this pattern showing up again. As soon as I recognize that pattern, I know that this is going to go on forever. Right? My decimal point was right here, so I have 0.6 repeating. So 2/3 is equal to 0.6 repeating. This again is a repeating decimal. If it does not repeat, if it does end at some point, that is called a terminating decimal. If you recall, our 5/8 was equal to 0.625, and it ended. That is a terminating decimal. This is a repeating decimal. If you want the exact answer for a repeating decimal, you give 0.6 with a bar over the top. Right? If you are asked to round your answer, say to the hundredths place, right, I need to write it out, 0.666, at least to the thousandths place. And then if I'm rounding here again to the hundredths place, I look at the number to the right. The 6 tells me to round up to 0.67. So 2/3 rounded to the hundredths place, 0.67. That would be my answer rounded, and then 0.6 with a bar over the top. That is my exact answer. That will cover it for chapter 3. Again, make sure you print off the chapter 3 homework and bring it to class. We will work on this more together in class. We'll take a look at some word problems. So please do come prepared. Don't forget to take notes on this if you need to. Go back and look at specific sections if you need to review them. And I will see you in class.